Hello, year 10, 11. Today we are looking at probability tree diagrams. This relates to exercise 10F in our textbook. For all of the questions in here, we're going to attempt to draw the tree diagram wherever we possibly can. We'll be working from the booklet. The examples in the booklet have solutions in our OneNote in the section 10F down the side here on mine. Yours will probably be the same. I'm working in there because there's more space to answer the questions, I think, and it will fit in a little bit better there for us. Okay, so 10F tree diagrams. In a probability tree diagram, we looked at this in around about exercise 10C, so this will relate back to that as well. The difference with our tree diagrams in 10F are that our probabilities are written on the branches. We can write a final column at the end that shows our outcomes or sample space if we like as well. One of the points I want to look at before we go into the question is this part in green. What we will be doing is we will be multiplying along the branches, and we will be adding as we go down the branches. So multiplying along and adding down. Okay, so let's have a look at the first example. A bag contains 6 white marbles and 4 blue marbles. So 6 white, 4 blue, we have 10 marbles all up. 3 marbles are drawn in succession. So that just means we're drawing one marble, we're going to draw another marble, and then we're going to draw another marble. At each draw, if the marble is white, it is replaced. If it is blue, it is not replaced. The tree diagram will be similar to what we've drawn before. We are just going to pop the probabilities or the fractions onto the arms of the tree diagram. So I've drawn one over here already. So we're doing 3 things. So we're going to have 3 sections in our tree diagram that relates to what we're doing. Okay, the first 2 arms of our tree diagram here shown in yellow gives us the information that's straight out of our question. And our question said we had 6 white and 4 blue. So we've got a fraction of 4 out of 10 for our blue and 6 out of 10 for our white. And as you'll note, I've highlighted those in yellow and written that they must add to 1. They add to 1 because our probabilities of something happening and something not happening, or probabilities encasing all possible possibilities, will always between 0 and 1, and here we have to have them adding to 1. That relates to our first marble drawn out of the bag. We've got the second marble and our third marble being our second and third vertical columns in our tree. So when we draw our second marble out, we're drawing a white and a blue and a white and a blue off each of these, but what it says is, if you go back to the question, 3 marbles are drawn in succession at each draw. So we're going to look at our second draw now. If the marble is white, it is replaced, and if it is blue, it is not replaced. So a white marble is put back in, a blue marble is not. So if you have a look, if we drew a white marble first in our first draw, then our second draw would still have 10 marbles in our container because we have put the white one back. So we've still got 6 white, and we would still then have 4 blue. So we'd have 6 out of 10 and 4 out of 10 here on our tree arms. If we go down below a little bit further, if we had drawn a blue one to start with, okay, what was happening with the blue? It was not replaced. So we no longer have 10. Our fraction in this section has a 9 on the bottom because we have put that one aside and we haven't put it back. So if we drew a blue one out first, then we would still have 6 white, but we would only have 3 blue. So our fractions there would be over 9, but note 6 out of 9 and 3 out of 9 will still add to 1. So there are arms for the second draw of the marbles. And we've got our third draw there as well. As you can see, I've got third at the top there. We draw white and blue arms off each of our previous parts of the tree, and then we're just going to think, what happens again? Our white goes back in, our blue is not replaced. So where we've drawn a white before, we now are looking at another white marble. We've still got 10 in there, okay, because this white was placed back in. We've still got 10, which means we've still got 6 white to choose from and 4 blue. However, if we'd drawn a blue one before, then that one isn't put back in and we only have 9 left. So we would still have 6 of the white because they are put back in, but we'd have 1 less than that 4 for the blue and we'd only have 3 left. Going down, have a look what happens down the bottom. Again, if we'd drawn a white here and a blue previously, we'd still have that 9 on the bottom because this blue wasn't put back in, but the white was, so that 9 is the same as this 9 here, so that this white was placed back in. So we would still have 6 white, but we would only have 3 blue because we'd already taken a blue out 2 steps earlier. Down on the bottom, this one's slightly different. This is looking at having drawn a blue and then another blue. And remember, this blue was not put back in. The second blue was not put back in. So we've gone down from 10 to 9 and now to 8. So just be careful here. We're looking at fractions out of 8. Okay, our white is still 6. We still have put our whites back in. So we've still got 6 whites to pick from. But 2 of our blue are missing now and we only have 2 8s of the blue to pick from. And our 6 8 and 2 8s need to add to 1 as well. If you would like, on the tree diagrams, I think I showed you this earlier on in class, we could write a column at the end that is called our sample space or our outcome column, and we could write what was happening. So I could write white, 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 which shows us this column here, white, white, blue, and show our sample space down the side. I'm not going to on this case because we're looking at fractions along the tree, and I think we need to look at the fractions anyway. Now let's look back at our questions. Now we've got our tree drawn. The first question says, find the probability of drawing no blue marbles. Okay, so if we're drawing no blue marbles, then we're drawing a white, and a white. Now, we go back to the tree, and remember how I said we multiply along our branches. So we're going to find where there's a white, and a white. That's along here. That's 6 tenths, 6 tenths, and 6 tenths. We multiply along, so we multiply all those together, pop them in your calculator. They break down to 27 over 125, or you might want to look at it as a decimal. It's not a irrational, it's not a recurring decimal, sorry, so we could use it like that. So that's the first one. The second one, the probability of drawing 1 blue marble. Okay, so 1 blue marble, let's have a look and see where we could do that. 1 blue marble could be drawn as a white, and a blue. So we'd multiply the 6 tenths, 6 tenths, and 4 tenths. Another way we could get a white, only 1 blue, would be a white, a blue, and a white. And we've got 6 tenths, 4 tenths, and 6 ninths. And our lucky last one is going to be a blue, and a white, and a white. And we've got 4 tenths, 6 ninths, and 6 ninths. So as you can see in brackets here, I've multiplied along my branches, and in between them, where we've moved down to another occurrence, we've added them together. So if we do all that, we end up on a calculator with 542 over 1125. I've written not to put that as a decimal because it is a reoccurring decimal that does not stop. So we want to leave that as a fraction if we can. Okay, 2 more to go. We're looking at 2 blue marbles and 3 blue marbles. Okay, so if we go along the tree, I'm going to let you look through this. So if you want to pause the video and see if you can find these fractions. For 2 blue, there's an option for a blue, blue, white, a blue, white, blue, and a white, blue, blue. So if you follow through the arms, you'll see we're going to multiply along the arms, and there's 3 arms to multiply, and we add those together to get our answer here. Probability of 3 blues, pretty easy. Blue, blue, blue. That will be our bottom line here, 4 tenths, 3 ninths, and 2 eighths, multiplying those, and we end up with 1 over 30. Okay, I'm going to have a look at the quick quiz underneath that was on your notes here. Quick quiz 4. It's not so quick, but we're going to have a look at that. So I'm down in 10F again. Let's jump in and have a look at that quiz. Just another question that relates to that this topic. So a bag contains 2 red balls, 1 black ball, and 1 white ball. And I've shown that in our tree here, red, black, and white. All up, we've got 2, 3, 4 balls. So my fractions are over 4. I've got 2 red, 1 black, and 1 white are my fractions. And you'll note where I've got them highlighted in blue, they add to 1. Now, let's read the next part of our sentence. Andrew selects 1 ball from the bag and keeps it hidden. He then selects a second ball from the bag, also keeping it hidden. So what's happening is there's 2 selections. There's our first selection down here. He picks that ball and puts it away. He keeps the second ball and then pops that away as well. And we can draw the tree diagram from that. And that's our first question, or our first dot point there. Draw a tree diagram to show all the possible outcomes. So what I've done here is we've seen the first draw here. The second draw of each of these colours, we've popped a red, black and white. And what we're going to do is then pop the fractions that go with that. So it says that we've drawn one ball and kept it hidden. So where we had it out of 4 for the first draw, our second draw is going to be all out of 3 because we've already removed one ball. We're not actually looking at a third draw, so we don't need to know that what happens when these guys get hidden, but we are looking at what happens between our first and our second. Okay, so if we've drawn a red ball first, it's gotten hidden and we've only got one red ball left, but we've still got that black and that white. What you'll notice is each of these thirds here add up to 1, which is what we want. Now let's look at the black ball. If I have drawn a black ball first, I've still got 2 red balls. I have no black balls now and 1 white ball. All of this will add up to 1. This part really, where there's 0 out of 3 for the black, doesn't happen because we're not drawing a black, but it's got the 0, so I've left it in there, but you actually could leave that little section out. So I popped that in there and said that that could not occur. Similarly, the same would happen with the white ball. If we picked a white ball out first, we could easily pick a red ball because we'd still have 2 out of the 3. With the black, we'd still have 1 out of the 3, but with white, we don't have any because we've only had 1 and it's been hidden. I put the 0 out of 3 there. We can put that through the maths. That won't make any difference to our answer. So if you didn't put that section in there and just left it as red and black, that would be okay as well because that's not really happening there. Okay, our question says, find the probability that at least, oh sorry, we missed the second one. Find the probability that both the selected balls are red. So that's our probability of a red and a red. So remember, we're multiplying as we go across and we're adding between our branches as we go down. In this case, there's only one case for a red, so we don't need an addition in there. We go to our tree, we find a red, it's 2 over 4 times 1 over 3, and that will break down to 1 out of 6. That one's fairly easy. The second one we need to think a little tiny bit more about. It says, find the probability that at least one of the selected balls is red. Now, we've looked at this before. When we're looking at least one, we need to pop it in to this little equation. So the probability of at least one red ball is going to be 1 minus the probability of no red balls. So I need to go through and look at my probabilities for no red balls and take that away from 1. So 1 minus the probability of a black, 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 white, white, black, and white, white. I'm multiplying across, those are those individual letters together, and I'm adding down. What you will note that we can't have a black, black, and we can't have a white, white. I've put those in there with 0 over 3, but they will go to 0 in our answer. So that is okay if we leave those in there. So what we end up with is a 12th and a 12th when we times those together. Add those together, 1 minus a 6th, and we get 5/6 for that answer. What you will notice is that's the end of the parts in the booklet, but there's more that I would like to have a look at because earlier on in the booklet, we had a look at some quick quiz parts. It was right at the start, and I said, no, we're not ready for those. We are going to wait until 10F. So I will end this video here and I'll pop a second one up that looks at those quick quiz questions 1, 2, and 3.